Welcome back. This will be questions 41 to 60 of the AWS Machine Learning overview. Hit the like button, subscribe, and share with anyone you know taking this exam. So, question 41. An engineer needs to use CloudFormation to create an ML model that uses that an SageMaker endpoint will host. Which resource should the engineer declare in CloudFormation to meet this requirement? Options are SageMaker Model, SageMaker Endpoint, SageMaker Notebook Instance, SageMaker Pipeline. So, the answer is SageMaker Model. So why is this correct? SageMaker Model defines the ML model resource, specifies the container image and model artifacts location, an S3. It's required before creating an endpoint configuration and endpoint. It includes the IAM role for model execution, CloudFormation structure with the model to the endpoint config to the endpoint. So the CloudFormation model deployment order, you see the create the model, create the endpoint config, create the endpoint. Why are the other options wrong? So endpoint requires the model and endpoint config to exist in the first place. Notebook instance is for development environment, not model hosting. And the pipeline is for training orchestration, not model development or deployment, excuse me. 42. An advertising company uses LakeFormation to manage a data lake. The data lake contains structured and unstructured data. The company's engineers are assigned to specific advertisement campaigns. The engineers must interact with the data through Amazon Athena and by browsing the data directly in the S3. Engineers must have access to only the resources that are specific to their assigned advertisement campaigns. Which solution will meet these requirements with the most operationally efficient way? IAM policies on a data glue catalog to restrict access to Athena. Store users and campaign information in a DynamoDB table. Create a Lambda to grant permissions dynamically based on the campaign. Use LakeFormation tag-based access. Tag resources based on campaigns. Grant permissions to engineers based on the tags. Create separate S3s for each campaign. Use bucket policies to grant access to the engineers. The answer is C. So the LakeFormation tag-based access control, or LFT-back, is designed for this. To tag the resources, the tables, the columns by the campaign, grant permissions based on the tag values, like the campaign assignments, right? This works across Athena and S3, centralizes permission management, scales efficiently as campaigns grow, and is the most operationally efficient, meaning there's a single source of truth. So how does this LFT-back work? You can tag data resources by campaign. You can assign tags to engineers. You can have LakeFormation and enforce access automatically. And it works for both Athena queries and S3. Why are the other options incorrect? So IAM policies on Glue does not control S3 browsing access effectively. DynamoDB and Lambda is over-engineered. It's high operational overhead. And separate buckets is not scalable. It's difficult to manage cross-campaign data. 43. Companies building a recommendation system. The system will provide product recommendations based on user browsing history. The company has millions of users, thousands of products. Which service or algorithm is most suitable for this use case? Personalize, SageMaker factorization machines, XGBoost, or comprehend? The answer is Personalize, which is purpose-built for recommendations. It handles user interaction data automatically, scales to millions of users and thousands of products, provides real-time personalization, manages cold start problems for new users and products. There's no machine learning expertise required, so it's fully managed. And there's multiple recommendation algorithms built in. So personalized features include user-based recommendations, similar items recommendations, personalized rankings, and real-time updates. Why are the other options incorrect? So factorization machines can work, but requires more manual implementation. XGBoost is for tabular data classification and regression, not ideal for recommendations. And comprehend is a NLP service. That's not for recommendations. 44. An engineer needs to perform feature engineering on a data set with 100 million rows. The data set is stored in S3 and Parquet format. The transformation includes joins, aggregations, and custom Python functions. Which solution will process the data most efficiently? So load it into SageMaker Data Wrangler and perform transformations. Use Glue with PySpark to process. Load data in a SageMaker notebook and use pandas for transformations. Use Athena to perform all transformations. B, Glue is designed for that ETL, large-scale data processing. So 100 million rows. PySpark provides a distributed processing efficiency, supports the joins, aggregations natively. It can run custom Python UDFs, user-defined functions. It's serverless, meaning it auto scales for large data sets. It's optimized for Parquet, and it's cost-effective for big data. Why are the other options wrong? So Data Wrangler is for interactive exploration, not production scale ETL, think 100 million rows or more. Pandas is a single node processing. This will run out of memory, excuse me. And then Athena is SQL only. It does not support Python functions. 45. Company deploys a model to production. After deployment, the model's predictions became less accurate over time. Model monitor shows data drift in several features. What is the most likely cause of the decreased accuracy? Answers. Training set was too small. The model is overfit. Statistical properties have changed. The model needs more regularization. C. So data drift means input data distribution has changed from training. So the model was trained on different data patterns. The statistical properties, meaning the mean, the standard deviation, the distributions, have shifted. The model assumptions are no longer valid for the new data. The common cause of degraded performance over time is typically this. And so Model Monitor is doing its job by detecting this and confirms the data drift. The data drift examples include customer behavior changes, market conditions involved, seasonal pattern shift, or new product categories are introduced. So why are the other options wrong? Small training set. So this will cause a poor initial performance, not degradation over time. Overfitting. This will show in initial deployment, not gradually. More regularization does not address the root cause of changing data. 46. An engineer is preparing to train a deep learning model using SageMaker. The training dataset is 2 terabytes and stored in S3. The engineer wants to minimize training time. What data input mode should the engineer use? File mode, pipe mode, fast file mode, streaming mode. Pipe mode streams data directly from S3 to training instances. It doesn't download the entire dataset before training starts. It reduces training time significantly. There's lower EBS storage costs, so there's no local storage needed. There's better large data sets, so 2 terabyte plus, and it's ideal for training jobs that iterate over data once. So file mode downloads all the data first, which is slow for 2 terabytes. Pipe mode streams the data as needed. Why are the other options incorrect? So file mode, we said that already. It downloads it first and then puts it into it. Fast file mode is not a standard SageMaker mode. And streaming mode is not a SageMaker data input mode. 47. An engineer is using a training job to fine-tune a deep learning model in SageMaker Studio. The engineer previously used the same pre-trained model with a similar data set. The machine learning engineer expects vanishing gradient, underutilized GPU, and overfitting problems. The engineer needs to implement a solution to detect these issues and to react in predefined ways when the issues occur. The solution must also provide comprehensive real-time metrics during training. What solutions will meet this with the least operational overhead? TensorBoard to monitor, publish this to SNS, create a Lambda to consume the findings and initiate the predefined actions, or CloudWatch default to gain insights about the job, use the metrics to invoke a Lambda to initiate the predefined actions, or expand metrics in CloudWatch with gradients in each steps, use the metrics to invoke a Lambda to initiate the predefined actions, or use SageMaker Debugger built in to monitor the training job, configure the rules to initiate the predefined actions. And the answer is SageMaker Debugger. This has those pre-built-in rules or built-in rules for vanishing gradients, GPU utilization, and overfitting. This automatically detects these specific issues in real time. It can trigger predefined actions when rules fire. It provides comprehensive training metrics out of the box. There's the least operational overhead. There's no custom code needed. And it's purpose-built for these exact use cases. So the built-in rules include vanishing gradient, low GPU utilization, overtraining, overfitting, and others. Why are the other options wrong? TensorBoard requires manual monitoring and custom Lambda integration. That's operational overhead. CloudWatch default doesn't capture gradients or model-specific issues. And then custom CloudWatch requires significant custom implementation, operational overhead. Next question. 48. A financial services company must ensure that machine learning training jobs and the data used comply with regulatory requirements. The company needs to track which data sets were used to train which models and maintain an audit trail. Which services provide this capability? SageMaker Experiments, or SageMaker Lineage Tracking, or CloudTrail, or SageMaker Model Registry. Lineage Tracking automatically tracks relationships between datasets, training jobs, and models. This creates a complete audit trail from data to deployed model. This tracks data provenance for compliance. It queries lineage programmatically for audits. There's built-in integration with SageMaker workflows. And it's purpose-built for machine learning governance and compliance. So what does lineage tracking capture? Data sets, the training job relationships, the training job, the model artifacts, the model, the endpoint deployments, and the complete reproducibility trail. Why are the other options incorrect? So experiments, this is for tracking experiments, not comprehensive lineage. CloudTrail, this is for API call logging, not machine-specific lineage. Model registry is for model versioning, not complete data lineage. Question 49. Company wants to detect fraudulent transactions in real time. Company is labeled historical transaction data. Fraudulent transactions represent only 0.1% of all transactions. What should an engineer do to address the imbalance when training the model? Use undersampling, use SMOTE, synthetic minority oversampling technique to generate synthetic fraud, remove the minority class, or use a larger neural network architecture. So SMOTE creates the synthetic examples of minority classes, balances data sets without losing majority class information, creates realistic synthetic fraud samples based on existing patterns, prevents models from ignoring rare fraud cases. It's better than simply oversampling, which just duplicates. And it's an industry standard for severe class imbalance, like that 0.1%. And the class imbalance examples are shown here. So why are the other options wrong? Oh, let me go over the class imbalances solutions. Okay, SMOTE, synthetic generalization. Class weights penalizes misclassifying, and anomaly detection is an alternative. The other options, why are they wrong? Undersampling. This loses legitimate transaction data. Removing a minority defeats the purpose because you can't detect fraud without fraud examples. A larger network does not address the class imbalance. Question 50. An engineer has developed a binary classification model out of SageMaker. The engineer needs to make the model accessible to SageMaker Canvas, to a SageMaker Canvas user for additional tuning. The model artifacts are stored in the S3. The engineer and the Canvas user are part of the same SageMaker domain. What combination of requirements must be met so that the engineer can share the model with the Canvas user? Choose two. The engineer and the Canvas user must be in separate SageMaker domains. The Canvas user must have access permissions to the S3. The model must be registered in the SageMaker Model registry. The engineer must host the model on AWS Marketplace. The engineer must deploy the model to a SageMaker endpoint. B and C. So Canvas needs read access to the model artifacts. That makes sense, right? The IAM role for Canvas must include S3 bucket permissions. This is required for Canvas to load and use the model as part of the secure model sharing workflow. And then model registry, C. So model registry is the central catalog for sharing models. Users in the same domain can access shared registry models. And Canvas can integrate with model registry for model import. This provides version control and approval workflows. And there's a standard method for model sharing in SageMaker. Why are the other options wrong? So same domain, so separate domains, right? Same domain is required for Canvas model sharing. Marketplace, this is for external distribution, not internal sharing. Endpoint deployment, this is not required for Canvas access to models. Question 51. A company is building a deep learning model in SageMaker. The company uses a large amount of data as a training data set. The company needs to optimize the model's hyperparameters to minimize the loss function on the validation data set. Which hyperparameter tuning strategy will accomplish this goal with the least computation time? Hyperband, grid search, random search, Bayesian optimization. Hyperband uses adaptive resource allocation with aggressive early stopping. It tests many configurations quickly, stopping poor performers early. The resource efficiency is there because it allocates more resources to promising configurations. It's particularly effective for large data sets when training is expensive. It's successive, having progressively eliminates worst performing configurations. It's faster than grid, random, or Bayesian optimization for deep learning. So why are the other options wrong? So grid search exhaustively tests all combination. It's the slowest approach. Random search is better than grid, but slower than hyperband. Bayesian is good for expensive evaluations, but slower for many trials. Next question. 52. Company needs to ensure that model training results are reproducible. The company wants to track the lineage of data sets, code, and model through the development lifecycle. The company also needs to search and filter metadata. Which solution would meet these requirements? SageMaker Studio notebooks with Git integration, SageMaker experiments to track and organize runs, systems manager parameter store to store data, metadata, or SageMaker lineage tracking to track and query the workflow. Lineage tracking automatically captures relationships between datasets, training jobs, and models. It provides a complete audit trail for reproducibility. There's no code changes required. It automatically tracks all SageMaker resources. It's searchable with metadata with filters and traversal APIs. There's visual lineage graphs in SageMaker Studio, and it's essential for compliance and governance. You can see the tracking when it captures datasets, training job relationships, training job model artifacts, models, endpoint deployments, and complete reproducibility trail. Why are the other answers wrong? So Git tracks code, not data lineage or model metadata. Experiment tracks metrics, but not complete lineage relationships. And parameter store doesn't provide lineage tracking capabilities. 53, company uses SageMaker for workloads. The company has a single SageMaker Studio domain. An engineer needs to implement a solution that provides an automated alert when SageMaker compute costs reach a specific threshold. Which solution will meet these requirements? Add resource tagging with using the SageMaker user profile in the domain. Configure Cost Explorer to send an alert when the threshold is reached. Add resource tagging with the SageMaker user profile in the domain. Configure AWS budgets to send an alert. Add resource tagging by editing the IAM user profile. Configure Cost Explorer to send an alert when threshold is reached. Add resource tagging by editing profiles and configure budgets to send an alert when threshold is reached. B. So SageMaker user profile tagging enables cost allocation by user project. AWS budgets is designed for specifically cost threshold monitoring and alerting. An automated SNS notification will be sent when costs exceed a defined threshold. The proactive cost management prevents unexpected overruns, and this can trigger automated actions via Lambda. How do you do this? You tag the SageMaker resources at the user profile level. You create a budget filtered by the tags. You set the cost thresholds and configure SNS alerts. So why are the other options incorrect? So Cost Explorer analyzes costs, but doesn't send automated alerts. And then C and D, IAM profiles don't support resource tagging for cost allocation. 54, company uses SageMaker for its workloads. The company's engineer receives a 50 megabyte Apache Parquet data file to build a fraud detection model. The file includes several correlated columns that are not required. What should the engineer do to drop the unnecessary columns in the file with the least effort? Download it to a local, perform a one-hot encoding by using a Python script, create an Apache Spark job that uses a custom processing script on EMR, create a SageMaker processing job by calling the SageMaker Python SDK, create a data flow in Data Wrangler, configure a transform step. D. Data Wrangler provides visual no-code interface for data prep, built-in transformations for dropping columns with point and click, native support for Parquet files, and preview transformations before applying. You can export it to SageMaker pipelines or S3. It's the least effort with no coding. So you can see the Data Wrangler features include visual column selection, correlation analysis to identify redundant columns, one-click column removal, immediate preview of results. And then we can go over why are the other answers incorrect. So the manual download. Well, that's incorrect because it requires significant manual effort. The EMR, this is overkill for a file that size. Then you have the processing job. So this requires writing custom code. So pay attention to what's said, and you can solve a lot really simply. Companies are creating, question 55, a company is creating an application that will recommend products for customers to purchase. The application will make API calls to Amazon Q Business. The company must ensure that the responses from Q Business do not include the name of the company's main competitor. What solution will meet this? Configure the competitor's name as a blocked phrase in Q Business. Configure Q Business Retriever to exclude the competitor's name. Configure Kendra Retriever for Q Business to build indices that exclude the competitor's name. Configure document attribute boosting in Q Business to deprioritize the competitor's name. A, blocked phrases. All right. So blocked phrases feature filters specified terms from responses. All right. You can ensure the competitor name never appears in any generated content. A simple configuration. You can add the term to a list of blocked phrases, and then you can guarantee filtering regardless of context. It's useful for brand protection, and compliance. Why are the other options incorrect? So, retriever exclusion. This controls data sources, not response content filtering. Kendra doesn't prevent terms and generated responses. Document boosting changes ranking, doesn't block content. Next question, 56. To use SageMaker to fine-tune a large language model for text summarization, all right? The engineer must follow a low-code, no-code approach. What solution meets this? SageMaker Studio, fine-tune an LLM, deployed on an EC2. SageMaker Autopilot, fine-tune an LLM, deployed by a custom API. SageMaker Autopilot, fine-tune an LLM, deployed on an EC2 instance. SageMaker Autopilot to fine-tune an LLM, deployed by SageMaker Jumpstart. D, SageMaker Jumpstart. So this provides a pre-trained foundation model, including LLMs for summarization. Autopilot integration enables low-code fine-tuning workflow. Point-and-click interfaces work with minimal coding required. And there's access to popular LLMs like BERT, GPT, T5 that optimize for summarization. And there's managed infrastructure, so no EC2 management is needed. And this is perfect for low-code, no-code. Why are the other options incorrect? So Studio with EC2 requires more coding for EC2-based model management. And then custom endpoints or EC2s, that requires operational overhead and coding. 57. Company has a machine learning model that needs to run one time each night to predict stock values. The model input is 3 megabytes of data that is collected during the day. The model produces the predictions for the next day. The prediction process takes less than a minute to finish running. How should the company deploy the model on SageMaker to meet these requirements? One is use a multimodal serverless endpoint, enable caching. Use asynchronous inference, set the installation count parameter to 0. Use a real-time endpoint, configure an auto-scaling policy to scale the model to 0 and it's not in use. Use a serverless inference endpoint, set the max concurrency parameter to 1. Answer is D. So the serverless inference uses pay-per-use model. It scales to 0 automatically. This is perfect for infrequent predictions. Wait. Okay, multi-model versus, yep. Okay, it's perfect for infrequent. It handles less than a minute inference time easily. There's a 3 megabyte payload well within the serverless limits of 4 megabytes max. And the max concurrency means that one appropriate job for the night. The cost optimization, right? You only pay for the minute of inference, not 24/7 hosting. So you can see the costs, right? The serverless, a penny a night, real time would be $50 a month, even if it's idle. So why the others wrong? Multi-model. I thought it might have been that. So that's unnecessary for a single model. Yeah, I knew it was serverless. Asynchronous, overkill for a less than a minute prediction. And real time can't truly scale to 0 instances. Okay, 58. An engineer trained a model on SageMaker to detect automobile accidents from closed circuit TV. The engineer used SageMaker Data Wrangler to create training data sets of images of accidents and non-accidents. The model performed well during training and validation. However, the model is underperforming in production because of variations in the quality of images from various cameras. What solution will improve the model's accuracy in the least amount of time? Okay, collect more images, use Data Wrangler to prepare a new training data set, recreate the training data set using Data Wrangler, and specify impulse noise options. Recreate the training data set using Data Wrangler, enhance contrast, specify gamma contrast. Recreate training data set using Data Wrangler, resize image transformation, crop all images to the same size. That's B. So data augmentation with impulse noise simulates image quality variations. This will train the model to be robust to different camera qualities. This will use existing images, so there's no time-consuming data collection, and training data will now match production conditions. It's a quick solution using Data Wrangler's built-in transformation, and the model learns to handle degraded image quality. The impulse noise benefits. This simulates sensor noise from different cameras, creates robustness to quality variations, and prevents overfitting to clean training images. Why are the other options incorrect? So collecting new images is time consuming. This is not least amount of time. Contrast enhancement. So this normalizes images, but doesn't create robustness to variations. And then resize doesn't address the quality variations issue. 59. A company has an application that uses different APIs to generate embeddings for input text. The company needs to implement a solution to automatically rotate the API tokens once every 3 months. Which solution will meet this requirement? Store it in Secrets Manager, create a Lambda to perform the rotation. Store it in Systems Manager Parameter Store, create a Lambda function to perform the rotation. Store it in KMS, use a AWS Managed Key to perform the rotation. Store it in KMS, use an AWS Owned Key to perform the rotation. The answer is A. Secrets Manager is the built-in, purpose-built for secrets rotation. Built-in support for automatic rotation using Lambda logics, Lambda integration with Lambda for custom rotation logic. It's automatic rotation scheduling for every 3 months. There's versioning and rollback capabilities, and there's an audit trail with CloudTrail. And you can see the features there: automatic rotation, Lambda rotation, secure storage with encryption, and integration with other applications. So why the other answer is wrong? So parameter store does not have built-in rotation capabilities. And KMS, this manages encryption keys, not application secrets or tokens. Question 60. A data science team is training multiple models simultaneously on SageMaker. The team wants to identify which hyperparameter configurations are performing best across all training jobs. Which solution will provide this visibility with the least operational overhead? Options are CloudWatch Logs Insights to query training jobs for hyperparameters, SageMaker Experiments to organize and track training jobs with different hyperparameter configurations, a custom dashboard in QuickSight by extracting data from S3, AWS Glue to ETL training metrics from CloudWatch into Athena for analysis. The answer is B. So SageMaker Experiments is purpose-built for tracking ML experiments. It'll automatically capture hyperparameters, metrics, and artifacts. There's built-in visualization and comparison tools. This organizes trials within experiments for easy comparison. It integrates with SageMaker Studio for visual analysis. And it's the least operational overhead. There's no custom setup required. What are the features? Automatic metric tracking, hyperparameter comparison, trial grouping and organization, visual analytics dashboards, and query and filter capabilities. Why are the other answers incorrect? So CloudWatch Logs Insights. This requires manual log parsing, and querying. QuickSight requires custom ETL and dashboard creation. And then Glue and Athena is a complex ETL policy pipeline with high operational overhead. So thank you for joining. We're going to get out of here. But before you go, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning exam. Thank you. Have a good day.